guys, we're getting started now. So what we're looking at, it's the end of the chapter actually. Oh, that's your laptop.
Yeah, it's not really working.
Even when you're not in my class, you're causing me trouble. It's quite impressive.
Yeah,
Right.
such abilities.
Okay. So as I was saying, this is the end of the chapter, and we're having a look at practical problems, which means there isn't any new rules. We're just looking at using the rules to story-based problems. So we'll start off with something, I don't know, something not too difficult. So let's say I ask something like add, so this is our first example. Can you see okay? Yeah. I'll pull that down in a sec. Add all, I got one. Add all 2-digit even numbers. So all of these problems are word-based problems. First one, get started. Add all 2-digit even numbers. So guys, come on. So what is the first 2-digit even number? 10. And then next is 12. And finishing at 98. Yeah? Yes? They're all the 2-digit even numbers. It's odd. Odd number. Even and odd. Yes. So, what type of sequence is this? AP or GP? AP. A starting with 10 and D is 2. And we'll have to get the N. So 98 equals UN, which is A plus N minus 1 D, isn't it? 88 over 2 is N minus 1. So N is 45, I think, if you were to work it, solve it. Bring over the 10 and then divide by 2. So the answer, S45, is N over 2, 2A plus N minus 1 times 2. So what's that equal to? Let's see, no calculator. 45 over 2, 20, well that's, what is it? 2430. Okay, so that's our first one, but we'll start making them more difficult now. Yeah. Where? 2A? Okay. Come on, guys. Quick. Is it 2430? Yeah? Yeah? Okay. Next now. Can I scroll down? Yep. Okay, so the next one is consider. Guys, come on. Guys, no talking, please. AP. Consider an AP. The first, second, and sixth term are also GP. And I also tell you it starts at 2. So, in fact, you know that it starts at 2. And I want to know what's the D and the OR. So just before I do this one, let me explain with an example what I mean. So if you were to take this sequence, let's say, I don't know, 2, 4, 6, 8, 10, etc. What sequence is that? AP or GP? It's AP, isn't it? Yeah. Now, if I was to pull out here, say the first, the second, and the fourth term here, I get 2, 4, 8. What type of sequence is that? GP. Yeah, that's kind of what's happening here. I give you an AP sequence, but I tell you that the first, second, and sixth term in it are also GP. Just kind of like in my example here with the number ones. Okay. So these are both AP and GP. These are the, but just be careful. What's the first one is going to be A. It doesn't matter what it is. If this is the second term in AP, what is this one? A plus D. Yeah, and is that right? Yeah, that's right. And then the last one, A plus 5D. Yeah. However, if they're also GP, then the first one could have also been A. Well, okay, that's the same. And the next one, if it's a GP, AR, and then the last one, squared. Because just like in this example, this first, second, fourth of the AP makes the first, second, third of a GP. There's a word to use to describe this. You would say the first, second, and fourth of the AP makes a consecutive GP, or consecutive GP terms. You know the word consecutive, meaning like neighbour in 1, 2, 3. So if we go back to this one now, we also know what the first term is. It's 2. So instead I could write 2 plus D and so on. What's interesting though, these are the same. The third term divided by the second term, what do I get? Yeah, and the second divided by the first? So, and these are equal, remember? So it should mean that this divided by this should equal this one divided by this one. And we know the A is 2, so we can say 2 plus 5D over 2 plus D. Yeah. 2 plus D over 2.
Now we can find C.
Yep. So it's just cross multiplying. Would it be? It might be quadratic. Let's see. So if we cross multiply,
4 plus 10.
yeah, 4 plus 10D is 4 plus 8.
2.
If I do the whole thing together,
4D.
not 4D. Thank you. Yes, 4D. Okay, it's looking like it's going to be quadratic. D squared minus, okay, so it's going to be D minus 6. Now, only one of those answers makes sense.
6.
6, yeah, why not the first one? D is 0. Yeah.
I guess it can be.
Well, it's not going to be a sequence if you're not adding anything, is it? So, D, it doesn't make sense. So, anyways, D is 6. And how can I get D or? Well, remember, what do these fractions equal? You said it earlier for me.
A R equal A divided over R.
Yeah, which simplifies to R.
R.
So 2 plus 6 is 8 over 2 is 4. Now I want to show you that this works. So let's look at the first, second, and sixth. So let's go up to 6. So we're starting at, where are we starting? 2. Add 6, 8. Add 6, 14, 20. Yeah, there we go. And third. Is that right? Yeah, that's right, isn't it? Yeah. Now, let's take out the first, what did I say? First, second, and sixth. First, second, and sixth. What do I get? I get 2.
2, 8, 32. 4.
Yeah, and or is the 4 then. So we can see that it works.
Yeah, how to calculate the first one? Like,
Which one?
on the first step, that he knows that R equal 4.
Oh, this?
Yeah.
Oh, yeah. I put it into here. 2 plus 6 over 2 equals R. Yeah. I've seen this in the exam. Not super common, but I have seen it in the exam. Okay. It was actually number 3 in the workbook, if you want to have a look at the question. Consider an arithmetic progression. The first, second, and sixth terms of the arithmetic progression are in geometric progression. The first term is 2. What's the common difference and the common ratio? Okay. Can we do another one?
Yeah.
Yes? We can scroll down?
Yeah.
Okay. Next one. I'll let you try it for a moment. What you have here, you have a ball that starts at a height of 1 meter, and then what happens is it falls down and bounces back up to a height of, next time we'll say 0.8 meters. Okay, and then again goes down, bounces up, and this time its height is 0.64 meters. So can you see what type of sequence this is? 1.8, 0.64? Yeah, but is it AP or GP? It's GP. It's GP. Because the difference between 1 and 0.8 is 0.2. And the difference between 0.8 and 0.64 is not 0.2. However, if you multiply 1 by 0.8, you get 0.8. And if you multiply 0.8 by 0.8, you get 0.64. What would be the next height? What would be 0.8 multiplied by 0.64? What is it? 512, is it? So I want to know what is the total distance travelled by the ball. So you have to add up all, yes, you have to add up all the distances here. Can you visualize that?
Yeah.
So you're adding up all these distances that travel. So I want to know the total distance that traveled. I would need to use which formula? Sn or S something else? S infinity, which is equal to A over 1 minus R. Yeah? Okay. Calculate that and see what answer you get for me. No.
Why?
What answers do we have? No. Huh? Yes, I think so. Do you know what he did wrong? What did he do wrong?
Oh.
Can you go with that?
Yeah. So, yeah. Yes. Let's have a look. So watch carefully, because I'd say most of the class would have gotten this wrong. How far does the ball travel at the beginning? 1 meter. And then it goes up and down 0.8. And then what happens? It goes up and down 0.64. Okay. Now you can change this into 1 plus 2 times 0.8 plus 0.64 plus 0.512, etc. Can you see what I did there? I just kept the one out separate, and because everything here is doubled, I just wrote it like this. 2 times all of that. Yeah? It's dropped from a height of 1. That's like its beginning. So, if I use my formula here, what's the A for this guy? Yeah, 0.8 over 1 minus 0.8. So that's equal to 1 plus 8, which is 9 meters then. This was in one of the end of semester 1 exam. For that particular year, I was working for NCUK, so I wrote the end of semester 1 exam, and I put this question in it, and I had exactly 0 students get this one right in the exam. I had many people tell me 5 meters. I had some people tell me 10 meters, and nobody tell me 9 meters. Okay, so my point is, for these questions, you have to read carefully and think about it carefully before you jump in. Okay? So write this one down carefully and we'll have a look at another example.
And the examinators told you what a wonderful question, yeah?
Huh?
And examinators told you that what a wonderful question, no one asked an answer.
They approved my exam and gave me the money, so for me that's a success. Anyways, you have to put one or two tricky questions in, just to see who can do it.
Just to see that no one can do it.
Well, I was kind of, what I do, when I put questions like this in it, I do hope, you know, like there'll be one person that just stands out, so I was a bit disappointed, anyways. No, no, it's not a good thing, it's not a good thing. Okay, let's see. Once you have that down, we'll have a look at another one. Yeah. Okay. Do you have that?
Second.
Yep. Now, the next one I'm going to do is one I've seen on one of the, who was it? Maybe it was Masrick or Charles. No, not Charles. Masrick. One of the medicine entrance exams. Now, it's a tricky question. It's not usually as difficult as what I'm about to show you. Because usually those exams are multiple choice, so the questions aren't too long to do. But this one was kind of a tricky one. Okay, can I scroll down?
Yes.
Yep. So in this question, you have a right angle triangle. And let's see. The sides are AP. And the perimeter totals up to 12. You know this word perimeter?
Yes.
Yeah? Okay. So yeah, we'll have a look at this one now. So the sides are AP and the perimeter total is 12. Okay. So what will we call the first side here? A, yeah. And this side? Maybe something different.
D.
What is it?
The hypotenuse is C.
No. A plus D. What are we making use of here? That the sides are AP. Yeah, and what will be the hypotenuse? A plus 2D. Okay. Now, we know that the perimeter adds up to 12. So we know that A plus D plus A plus 2D, that should equal 12. So that's 3 A's there and 3 D's. Do you need me or are you just passing? Okay. 3 A's and 3 D's totals up to 12. What can I divide through here?
It's like looking at 3.
3 divide out, so I get A plus D equals 4. Now, this is helpful, but what else do we need? I mean, is this enough to solve? No, so we need something else, don't we? What could we use?
Oh, S.
Yeah? No, not sign. No, not sign.
Yeah, 3, 4, 5.
Yeah, that's going to be, yeah, but how can we get there to the answer? Pythagoras.
Yes.
Pythagoras. Yes?
Yeah, just said it in Russian, ask like with how you spell it? Can you
Pythagoras.
write it?
What's it in Russian?
In Ukrainian, Pythagoras.
Oh, sorry, what is it?
Pythagoras.
Oh, I would have understood that. That's not that
Yeah.
different. That's not that different. Okay, so we use Pythagoras and we get A squared plus A plus D squared plus A plus 2D squared. That's equal to, that's equal to that, yeah.
I was
I got carried away there.
what I missed.
It's a alternative version. Yeah. But we don't know the area. You know, if I knew the area, that would be a good one to use. Be simpler, you know. So we've seen this type of problem before, haven't we? What type of problems are these called? What lesson was this? No, but which algebra lesson? Yeah, the one after simultaneous. One linear and one quadratic, because they have a square in it, you know. So what way do we solve these?
Oh, so we just put.
We'll put this one here.
Now we have like a quadratic plus 4.
Which should we replace, the A or the D?
D.
Maybe D, because you only have to replace the two of them. I think it might be. D equals 4 minus A. So then I get A squared plus 4. Oh, yeah, just 4.
16.
Yeah, 16. And then that would be A plus 2D, or that would be plus 8 minus 2A squared. So that would be A squared plus 16 equals, is that minus A plus 8?
Yeah.
Okay, that's A squared plus 16 equals A squared minus 16A plus 64. Now that's nice, because what cancels on both sides? The A squareds nicely cancel. So I get 16A, yeah, isn't that right? Equals 64 minus 16, isn't it 48? So what does A equal? 4, isn't it? Or 3. And if I sub that in there,
We'll get 5.
what does D equal? 1. So, no surprise, it was exactly the triangle you guessed. The 3 sides here, 3, 4, and 5.
Yeah, how do you call it?
How call which?
Oh, the triangle that's.
Oh, well, you see, we would just call it a 3, 4, 5 triangle, but you could also call it a Pythagorean triple.
We call it Egyptian.
Also, yes, I have heard of that term before, because they had it first
Yes.
for the pyramids with the ropes. Yes, that's probably why. But no, it'd be more normal to call it here a Pythagorean triple. You make Pythagoras name an adjective and then triple, as in the 3 numbers for it. So 5, 12, 13, or anything like
That
this.
I know it will be more than enough. Not even remembering all these names.
Okay. Pythagoras is enough.
Yeah.
Is this okay? Huh? Yeah, but it's a special type of right angled triangle because all the sides are whole numbers. So in English we call that a Pythagorean triple. When you have the 3 sides are 3 whole numbers. Yeah. Right angle is just any type of triangle with a 90 here. Yeah.
Like here you can use, like, for example, if you know that this side is 3 and that side is 5, so automatically the other side will be 4, yeah.
Yeah. Question? No? Okay. Another example here. I want to do 2 more examples. Guys, listen please, listen. 2 more examples. Yeah, one finance and one biology example then. Yeah. Okay. So next example. When you have something like, guys, are you listening?
Yeah.
So take something like €100, for example. So in most banks, certainly Western banks anyways, what happens is if you deposit €100 into the bank, so the bank has your €100, what the bank does with that €100 is it lends out 90 and it only keeps 10. Now you might say that's a little bit of a problem, because what happens if later that day I come back looking for my €100 and they only have 10? Exactly. So it's fine as long as there's somebody else who did the same thing and they're not coming back looking for their money. So as long as the bank has enough customers, it can still give the money back. even though it doesn't have your exact money. Okay? I don't know if this is a concept you've seen before. Yeah? So, what then happens is this person who got the 90 euros as a loan from the bank, they spend that money, and then that will end up, naturally enough, in another bank account. And what will happen with that 90 euros? Well, the bank does the same thing. It will keep 9 euros and then lend out 81 euros. Okay? So your 100 euros caused you to still have the 100 euros because it's still on your bank balance, but now somebody else on their bank balance has 90, and somebody else now has 81, and so on. Okay. Usually banks keep 10% of the money they receive as a minimum, and then lend back out the other 90%. So I would like to know how much money is now in circulation. So there's the original 100 that you have on your bank balance, and then some other customer now has a 90, and then some other customer now has 81. So what type of sequence is this, AP or GP? GP. Let's calculate the total, S infinity. So what's the A? 100, and the OR? 10%. So what OR is that? Now look carefully what's happening here. 0.9, yeah. So this is 1,000. So, can you all visualize the pattern that's happening here? If I put 100 euros into the bank, maybe that bank, you know, somebody has a credit card, maybe that bank gives her 90 euros, and then she spends it in Spar, and it goes into Spar's bank account, and then another person gets 81 euros, and so on. Where would all this money go if I put this 100 euros under my bed? Would there be 1,000 euros available? No. Would it be available? No. No. Because it only worked because I put in the first 100. So I just want you to appreciate something here. The government printed how much money? 100 euro note. But how much money is in circulation? 1,000. So although the government made 100 euros, the bank produced 900 euros. Okay? So people kind of think that governments print money. But they don't really print money. It's actually the banks that print the money through this process. Okay? So I don't know if you're picturing, oh, all the money comes from the government and they print it, and this is how we have all our money. You can see that most of the money actually is coming from the bank accounts.
It's like a cycle.
Cycled around, yeah. Yeah? I think, now you see, I know this is how it works in Western countries. I don't know if it's a little bit different in countries that have, halal banking, or the, I don't know what it's called.
No, we just don't have the usual stones.
How does it work?
Kind of
I can't hear. I'm trying to learn something new.
It's kind of similar, but like we don't have interest rates in certain.
But it's the same idea that if you went into a bank and put in 100 euros, same basic idea, that 90 euros would end up in another bank, and so on. The only difference is there is an interest being charged along the way. Okay, but it's the same concept.
Yeah.
Same concept. Okay. Does anyone know the name of this concept? Does anyone? Does anyone know the name of this? Anyone study economics? You might have known it at one point. Anybody? No? F. Fractional lending. Yeah. Not that difficult. Not that difficult. Fractional. You're lending a fraction again each time. Yeah. All right. Can you write that one down? Hang in there. Okay. Now, next example. Can I scroll down?
Yeah.
So the last example I want to do with you before you try some of these is a biology example. No, not mitosis, no. Okay, so something that you may or may not know. A male bee comes from an unfertilized egg, so it has only a mother, whereas a female bee comes from a fertilized egg. So, for example, if you had a male bee... Guys, I need you listening. There's lots of talking during this hour. Can we listen, please? So, if you have a male bee, you know that it had only a female generation before it. Okay? In other words, male bees come from unfertilized eggs, whereas if you had a female bee, they always come from fertilized eggs, meaning they must have had both. I don't know if this is something, it's not something I don't think you would do in biology class, but I don't know if anyone's seen that before. No? So anyways, the key idea here is that for bees, eggs, when they're not fertilized, they always become male. And then when the egg is fertilized, then it will always become female. So it's kind of an interesting way to control the genders in the hive. If the egg is left unfertilized, it will be male, and then fertilized female. So what we have then, let's start off with a male bee. So that can be generation 1, and then its ancestor generation G2, and so on and so on. So let me just draw that for you. I'll start at the bottom so you can visualize it. So you start off with a male bee, that's generation 1. How many's in this generation? 1. Just start with that. Its ancestors, generation before it, G2 we'll call it. Who was in this generation?
Female.
Just female. So again, 1. Generation 3, who was in that one? Male and female. This is in just generation 2. Now you can see how it starts to build up. Generation 4, this male bee had just 1, and this one here had female and male then. So now we're at 3. Okay, let's do one more. Generation 5. Right above this one is male and female. This one here, MF, and then this one here, M. Yes? Sorry, F. How many here? 5. Now, this sequence, if I just write it out down below here, 1, 1, 2, 3, 5. Does it look familiar?
Yeah. Triangle.
Not triangle, what's it called? Fibonacci, yeah. You add the last 2. So my question here was just what is G10, so let's just go up to 10. 1, 2, 3, 4, 5. I need 6, 7, 8, 9, 10. So here, 8, isn't it? 21, 34, and 55. So 55 in the 10th ancestor generation then.
G100.
That'll take longer. This is only G10.
There's no formula to
There is. There is a formula to calculate GN. Yeah. It's not. I can't remember off the top of my head. It's not too difficult. It's something of the form GN is some number to power plus some number to a power over some other number. It's not really too difficult. I just can't remember the constants. Yes, because otherwise, if you were to go to G100, it would take a while.
Here it is.
Okay, can you write that one down? That's a biology example.
Why isn't there an answer in the book?
For which one? Because I added this question in last year and forgot to add in the answer with it. That's why. So yeah, you can write it in. 16, the answer is 55. Yeah, there it is there. 55. Okay, now I just want you to try these for a few minutes, okay? Really, you need to be doing all of these because you can see each question is different. Students find these difficult in the exam because you don't really know what you're going to get. They're all practical problems with a different story each time. So it's good for your experience if you do try all of them. Now the first few aren't so difficult, but towards the end you start getting ones like this. Yeah, you really want to be doing all of these, okay? So you can get a start on them now, please.